Good afternoon, everyone. We're really excited to be here this afternoon to talk about a very exciting topic, explainable AI. We hear a lot about that in the media. There's a lot of excitement in the Valley about building AI systems that can be explainable. We're going to talk about a range of aspects of the whole problem and challenge of building explainable AI systems. But maybe to start out, I'd like to ask Trevor and Krishna a question of, why do we need explainable AI? So, I've got a dishwasher and it's not explainable, or when I use Excel, it doesn't explain anything to me. Why do you think, are we unfairly setting a bar really high, or why do you think we need explainable AI technologies? Krishna?
Cool, yeah. Hello, everyone. I'm Krishna. I'm founder and CEO of Fiddler Labs. We are an explainable AI startup in Palo Alto. The question of explainable AI for us is, a lot of industries are adopting AI today, right? However, when the risk of doing something harmful with AI goes higher, then I think humans want more transparency from the system. I think it was okay when machine learning was deployed at scale to serve ads for a long time, and we've had that. Large companies do it. We're used to it. I think it's okay to see a bad advertisement. It's not harmful. But let's say if I apply for a loan and I get rejected and in a biased manner, or if I apply for a job and there's an automated system that's making a decision to, kind of approve my resume. Or similarly, if there is like a healthcare diagnosis being done by an AI system, this is where humans want more transparency, more accountability from both the systems and the companies that are building the systems. And that's where you need kind of this trust and explainability aspects come into the picture.
Trevor, your thoughts?
I think we want explainable AI because we want AI systems that are actually very effective and robust. And especially as we get to more exciting challenges in robotics and perception, complicated toilets, autonomous driving in challenging environments, or even just building products that move from the lab into the real world. I think all of us who work with the technology are often not surprised to see how it doesn't work in a challenging new environment. Things break. There's a domain adaptation or domain shift in between one environment or the other. Something just doesn't work. And when you train something as a black box, these deep learning models that are driving much of our success are wonderful and powerful. But when it's a black box and it just doesn't work, it's very unsatisfying. So we're driven at Berkeley in our investigation of XAI, I think, by building systems that are just more effective, and they're more effective because when they learn, we train them to essentially show their work and open up their black box just a little bit, or enough so that humans can get in and have a more effective process of training them, using them, and trusting them.
So one of the big challenges in getting explainable deep learning in particular, to focus on a particular very popular type of AI these days, right, is the problem that those are very numeric, mathematically oriented techniques. And when we talk about humans and lay people in particular and wanting to explain the system to them, people tend to think at higher cognitive levels. They tend to think symbolically. They tend to think in terms of generality, not in terms of large multi-dimensional vector spaces. So is this a gap that we can bridge in the technical community? And could you say a little bit about how in your work you're trying to bridge that gap? Trevor?
Sure. I think that's exactly the right way to frame the problem. And historically, actually, there's been this, I think, misnomer about explainable AI, that if there's a trade-off, you have to either pick systems that are effective and uninterpretable goo because they're these awfully large parameter spaces, or they're explainable or interpretable, but they are in a hypothesis class that's so simple that they'll never actually be effective. And there's like a famous, do you want a doctor who's effective or can explain themselves? And if you define the problem in that way, you're going to end up with that trade-off. But I don't think that's actually reflective of the real world of how we are conducting AI research. The benefit of an explainable perspective on a deep learning system is one that may have modularity and multitask training setups where you actually train a model and constrain a model so that it learns to have some internal structure that it can then represent to you. If I'm solving a vision task or a vision and language task where I have to count how many red cars are lined up in a row in front of me here, I would like to have something that's compositional and can tell me this is the part that's counting, this is the part that's looking for red, and this is the part that's looking for cars, and I can independently inspect it. And that's what we call an explainable system. And that system may have more performance because it can actually be trained or corrected or advised, to refer to some ideas that I know Karen is interested in. And last but not least, an explainable system can outperform a non-explainable system in a context where there's a human in the loop, and the human is part of a team, human agent team. And the human can observe the explanation and decide whether or not to accept or trust the recommendation of the explainable system. So for example, I'm mostly a computer vision researcher, so you'll hear those examples from me, image salience models that show you what the model was relying on, and you can see, did the model actually rely on the right reasons that make sense, and therefore I will accept its recommendation as to what species this bird is. Or if it's looking at the wrong thing, well, that helps me. And so in the context of a human agent team, we escape this trade-off of performance and interpretability.
Yeah, I think I completely agree with Trevor. I mean, the kind of trolley questions that I think there was a recent viral tweet around, would you go to a black box AI surgeon with 90% accuracy, or would you go to a human surgeon with 80% accuracy? Those kind of trolley situations don't really happen in real world, and I think what we want to aim for is explainable system where there's human in the loop, both in the development of the system, but also in a way that when they're actually providing the decisions, they actually have that necessary transparency, so they can either approve or go with the system decisions. And I think for us, like when we think about explainability, we want to look at various stakeholders inside explainability. As Trevor pointed out, the developers want to use explainability to build better models and kind of continuously improve the AI workflow. But the users of models, the business stakeholders, the customers, want to use explainability to develop trust and comfort with the system. Because essentially, when we are moving from legacy old systems to AI-based systems, and these systems are percolating into businesses, what people want is a level of comfort that they can actually assess the system and assess the risk around the system and get the transparency to either approve or reject the system's decision. And finally, there's obviously government regulators that are out there that are coming in and kind of like checking these systems for compliance reasons, and so like an explainability system would sort of cater to all these variety of users, and I think and in the end we would be able to develop a better AI overall if we adopt the quote-unquote explainable way of doing things.
So one very intriguing and popular approach to building explainability into deep learning systems is to actually have a learning system that sort of experiments with the learned model and sort of probes it, and then can sort of learn its own model of how the system is operating. This is a so-called black box technique because it doesn't have to look at inside the learning process or directly look at the learning models themselves, but rather just formulate hypotheses about what's going on by probing how the model would behave on different kinds of inputs. So that's a really interesting area that a lot of people are exploring. And Krishna, I know that at your company you're looking at that technique. What do you say to the criticism of, it sort of turtles all the way down, right? You're putting another learning system on top of a learning system, and how can you trust that learning system is actually doing the right thing?
That's a great question, right? So we often get the question, is like essentially you're putting Fiddler on top of a black box model, so why do I trust Fiddler in the first place? So I think it comes down to fundamentally how do you assess explainability, right? How do you evaluate explainability? That's gets into a little bit of philosophical questions. Let's say even with our human let's say this is basically a neural network inside your brain, and we're able to recognize that as a TV. Why, you can ask me, why is that a TV? I can say, that's rectangular, some light is coming through it. Maybe you can say, I'm going to make this a circular. Would you still call it TV? Then I would say, yes, it's a TV. So, I mean, there's various layers of assessment. So there's no one explainability that actually would say this is what is actually allowing the model to kind of predict this way. So what we provide at Fiddler is, what we call a holistic explainability, that one can assess the model in various different angles and be able to like compare and contrast with various different profiles. So for example, let's say you're using black box explainability for assessing credit risk, and someone applied for a loan and got rejected. Now, why was this person rejected? Now, like you can then ask questions. Was it his income the reason? Was it her FICO score? Now compare with the different demographics of people. And so now you can form a holistic opinion of why this person was rejected, as opposed to, oh, these are the features that are important, and therefore the decision of the algorithm was so and so. And so, essentially the approach that you take to provide the explanation will basically help build the trust with the user that's using it.
To build on that example that you just gave, right, so you're explaining, talking about explainability in terms of the content in the model and how it might apply to, say, a particular individual and their credit score. So that kind of raises the question, the companion question then about the data itself. So there's been a lot of emphasis on explaining the learned models or even potentially the algorithms that are generating the models. But given this whole issue of bias, that is a very important one for the field of deep learning as a whole. Do you see any great ideas? Are there interesting things happening in terms of actually explaining the impact of the quality of the data, the amounts of data on the type of models that are being learned?
Yeah, that's a great question. So I think the way you can think about explainability is if you feed in bad data into the model, if you feed in biased data sets, then the model will perform in a biased manner, right? And so when you think about explainability, it's not just enough to assess it at the end of the model production once you have a model produced, but you also need to think about, like data explainability, like how is the data set actually constructed, and which parts of the data are contributing for this model decision. So for example, let's say this, again, coming back to that credit risk prediction, now one can say this person's credit risk prediction was low. Now, what were the examples that were feeding like this prediction to behave this way, right? So, and then you can go dive deep into the data set and see, was it actually a feature problem? Was it a training set? Do you have enough positive labels for this type of individuals, and therefore kind of like go further. So, coupled with model explainability, you also need to have a way where you can actually sort of slice and dice the data sets and then see where the problem is. It's not just the algorithm that could be a problem. It could very well be the data and the features that you are actually building on top of it.
Okay.
I can add a riff on that as well. I think that explainable systems are a key tool on the path to debiasing certain AI algorithms, a project that we worked on at Berkeley in the realm of image and language, visual captioning. We showed how explanation systems that can confirm that a decision is made right for the right reasons, quote unquote, would help remove bias in a data set, for example, regarding gender roles. The image captioning system, when we looked at explanations, it turned out to be deciding what gender to refer to a person in the image based on what room they're in. The data set's horribly biased. If it was in a kitchen, all of the training data used a female gender, and if it was in the garage, it used male. And so you can use explanations to impart knowledge that one has, that future domains won't have that bias, or that we have a policy that we don't want to have our system to reflect that bias. And so by enforcing constraints on the explanations of the system to say, you should actually be deciding how to, what pronoun to use based on the actual appearance of the person in the image, or other constraints that you'd like to impose that might even be more sensitive than that, it gives you a toolkit to have more fair representations.
So people like Gary Marcus would say, well, you're not you personally, the field as a whole is going about this the wrong way. I mean, that's a great example of something where you should be pulling in common sense. And if you were modeling explicitly that, currently a lot of women work in the kitchen, and then that should be something that a lot of women prepare the family meal, that would be something the system would be able to reason about and draw appropriate conclusions from that. Is that something that you think to really achieve good explanation quality, we'll have to start pulling in good old-fashioned AI and lots of background knowledge?
I'm a big fan of common sense. and I hope we get there, and I think it'll be a combination of newfangled and old-fashioned AI. So I'll just say yes.
Okay. Trevor, I'd like to follow up on a comment that you made several minutes back where you raised this question of advisability. And I think one of the reasons that explainable AI is such a hot area is because it's viewed as essential for trust. But Trevor and I were talking before we came on stage about there being other dimensions of trust. And one of these is advisability, or in the work in my lab, we call it directability. But really this capacity that humans have control over the system so that if it's making mistakes, you could go in and change the models, change the behavior so that the system maybe continuously learns over time, but perhaps even more importantly, though, that there's this feeling of control that the system isn't driving you, you're driving the system. And Trevor, I know your team has been doing some interesting work in this space. Do you want to explain your approach?
I'll explain and advise, I guess, on the approach. We've been doing something that's very complementary to the ideas that Karen just outlined. And I think that the high level, if there's one thing I want to get across today about explainability, to me explainability isn't just about feeling good about a model or some sort of like hand-holding or feeling of trust. That's nice to have those things too, but I'm most interested in explainability that actually makes models perform better. And in this case, we built explainable systems. Maybe this class of explainability was more justification systems. We built systems that allowed you to transduce the internal state of an agent, a driving agent or a recommendation agent, and have it generate text saying what was the reason that that prediction was made. And we did this really just using an image captioning system that was then conditioned on a decision. And we can talk about that technical architecture and debate whether it's causal or not, or whether it's actually an explanation or a justification. But one thing you can immediately do is turn it around and run it backwards, and then have people provide additional training data to the model, not by generating new images or behavior examples, but by actually just providing text. And the text might be something, for an example, in an autonomous driving system, pay attention to the pedestrian by the side of the road. And so this is an actual example that's done in the work coming out of Professor John Canney's lab that my lab collaborates with, where the training data apparently didn't have any pedestrians in certain environments, and the model only paid attention to crosswalks because there were no jaywalking pedestrians in the data set. And so it actually becomes very useful. So you could go out and collect a whole nother data set forcing people to jaywalk and try and have that. That's very expensive. It's much more normal to just say, pay attention to the pedestrian. You should actually, that person was an important cue here of how you should behave. So we call those advisable systems.
I think today, constrained deep networks, constrained boosted trees are definitely gaining adoption, even in a quote-unquote regulated, highly regulated industries. Like I keep coming back to that financial services example because that's kind of where we are focusing on today. So we are working with fintech companies in San Francisco where they, especially they're applying machine learning, complex machine learning techniques for lending. And the way, if you just apply, let's say, a boosted tree, even forget about a neural network, a boosted tree for a lending example, you could get, unrealistic explanations. You could have a situation where, your credit score will go high if you pay back a few loans installments, and then you don't pay, you pay 3 installments, it might drop. You pay 4 installments, it might go high, and no regulator would be very happy with it, not even the customer, right? So what you do then is, as Trevor said, in the training process, you impose these constraints that, a FICO credit score and, repayments have a monotonic relationship. You're paying consistently, then your credit score should go high. So by applying these constraints during the training process, you not only explain them, but the explanations are also rational, that you can actually, they're realistic. And I think that's very important for explainable AI to succeed, that they're just not like justifications for a compliance sheet, that they actually make sense for the consumer.
I'd like to turn the question back to the moderator to hear more about the advising work at SRI.
Sure. Thank you, Trevor. We're looking at a couple of different approaches. One is similar to the style of approach that you were talking about, where you can have symbolic information about a domain, representing constraints, rules, whatever you like to call them, which capture a user's expertise or background knowledge, and then trying to marry that then with the various kinds of learning that you might be using. So What we're trying to do there is maybe a little bit different from what Trevor talked about in terms of not just sort of using that directly as training feedback to constrain the learning process, but also in terms of actually creating the architectures, the deep learning architecture. So using complex constraints as a way to set up what those architectures look like. Still early days on that work, but it looks really interesting. And a different approach that we've been exploring is one where you actually try to use human guidance to generate training examples. And what's nice about that is you can pick your favorite deep learning algorithm implementation off the shelf, and you don't have to change it in any way whatsoever. What you're doing is biasing the data that you put into it such that the data that you're putting into it is reflecting these constraints that you have about how you would like the learned models to behave. So one of the people in my lab who's doing this work, of course, he's doing this in the context of games because that's what everybody does in the field, right? But something like, avoid lava, right? So that's something that you shouldn't have to give your deep reinforcement learning system, 500,000 examples where they die because they went into the lava. You'd like to be able to just tell it up front, just avoid that. So our approach then would generate those many examples and then bias the learning process in a way because it's seeing lots of examples of staying away from the lava. So thanks, Trevor, for that little plug. Let's see, we probably have time for one last question. I was going to bring up a little anecdote from a panel I was at a couple of years ago. It was about self-driving vehicles, and it was really interesting. There was a VC panelist, and she was very rah-rah, and she got up and said, we're going to have self-driving cars. They're going to be on the road next year. They're going to be all over the place. So that's great. We have that enthusiasm coming from the VC community. Then we had a technologist, somebody who's very well respected in the field, and she said, well, I'm not quite that bullish. I think we'll have like self-driving trucks. We'll have limited, highway driving. Probably 10 years we'll have it out there. And then there was a lawyer from one of the big 3 automakers, and she stood up and she said, we're never going to have these things on the road. And her big concern was really this whole issue of accountability and being able to, if something went wrong. She gave this example of if a couple of problems manifested themselves in one of their in a self-driving vehicle product that they had on the road, and they couldn't explain why that was happening. According to government regulations, they'd have to pull every single car off the road until they could figure out how to fix it. And then she was starting to talk about, well, is the problem in the learned model, or is the problem in the data, or is there a problem in the integration between the two systems, or is there a hardware problem somewhere that's causing this? And she went through this whole litany of possible problems. So Krishna, maybe you could comment on that, because I know you feel very bullish about getting this technology out into the real world very soon. Maybe you could comment on why you're bullish about that.
Well, this is exactly the reason why you need explainable AI, right? So, because I think, humans tend to hold machines at a higher bar than humans themselves, right? So there are probably a lot more accidents happening with human drivers, but if there's one accident happens with a self-driving car, then that becomes a big story, and you want to get into why that's happening, and that's okay. I think that's quite common. That will be the case. Now, therefore, when we are basically introducing AI into these high-risk use cases, you need to have explainability, not just like to justify how it's working when something bad happens, but also to build a better AI overall. And I think it's quite important. Like today, like when stakes are high, when companies are thinking about AI, and they need to sort of like think about should I go the black box way or should I go the explainable way? And that's kind of why, that's one of the main motivators for us to start the company, because previously I was at Facebook and I saw like what happened when we had really complex machine learning models powering various different Facebook products, especially like newsfeed, and we kind of lost a little bit of the transparency. It was very hard to debug even for the best engineer at Facebook, why someone was seeing a story and in their newsfeed, and I think and that's going to happen more and more across the board.
Okay, we've got about 30 seconds left. Trevor, let me put you on the spot and just say, when will we see explainable AI out in commercial products?
Well, I'm going to pivot and answer a different question, which is to say, I think there's so much promise in explainability that it will lead to robustness, that it's also in many ways the fulcrum of bridging deep learning and symbolic AI. But the cautionary note I have is that I even think what is an explanation or what is explainability is itself a research question that's almost as interesting as some of the techniques and technologies we're developing, which is why I can't really answer the question in a simple way, because I don't really, I'd have to first tell you the taxonomy of different kinds of explanations. So I'm sure there already are simple explanations in Fiddler's offerings and others, and in the major credit houses. But is that a full explanation? Is that a human level explanation? Is that an explanation that has legal responsibility? I would caution, it's an exciting area, XAI, but it's also a very dangerous area to assert anything. And different people use the word very differently when whether you're talking to regulators, vision and language researchers such as myself, and startup folks. So I'm always kind of maybe have a reality check and define the terms more than just saying explainability in order to avoid confusion.
Great point. Okay, with that, I think we're out of time. Thanks very much to my fellow panelists up here.
So thank you.
Thank you.